Good morning, everyone. My name is Roger Tawfik. I go to the University of Massachusetts Amherst, and my research project is on the automated quality control checks for clinical gait videos under Dr. Banaz Garani. So just as a quick overview, I want to establish my goal, and that is to compute accurate gait metrics through 3D human pose estimation. And this matters because gait metrics can actually reveal early signs of Alzheimer's disease and other related dementias. However, we do run into a problem, and it's that pose estimation is only as good as the video that it receives. So we can ask, or we can see what can actually go wrong in a given frame. So on the image on the right here, we have a person who is being occluded by a pole. There are so many other things that can go wrong. The frame itself can be blurry. There can be a second person in the frame. Our feet can be out of the frame. And there are so many things, and that is actually the gap. The current clinical gait pipeline system does not reject a unusable video before sending it off to analysis because they assume that the video is already good. And this is where I come in, and this is what I plan to fulfill with my front end. So like I said, without that quality control gate, we are essentially recording a video and sending it straight off to gait metric analysis. So then we would pass videos like this, which include frames where I'm actually being occluded by a chair very clearly. With this quality control gate, we are recording a video, running it through a set of checks, and then deciding whether to pass it or fail it. So a little bit more on the system and how it actually works. Like I mentioned, we start off with a recording, and then we send it to our computer vision model, OpenCV, for some video level checks. After that, we send it to our two lightweight pose estimation models, MediaPipe and YOLO, for the joint level checks and the person level checks, respectively. And then after we get the output from the pose estimations, we send it to an LLM for a plain language verdict. And from there, we decide either to pass it or fail it. If we pass it, we send it to MeTrabs, which is our 3D pose estimation model, which actually calculates the gait metrics themselves, stuff like cadence, step length, stride length, velocity. Otherwise, we fail it and we prompt the user to re-record. So a little bit more on the checks themselves. Like I mentioned, we have that kind of three-stage system, the video level, the person level, and the joint level. We always start off with vial validity, right? We need to make sure that the video itself is usable, is not corrupt. We need to make sure that the person in frame is actually portrait, right? And we're checking for things like a valid frames per second, valid resolution. And then after that, same thing with OpenCV. We use it for lighting and blur because it is easy to compute. We don't need to process every single frame to decide if the lighting and the blur are in check. So after that, we send it off to YOLO for our person level checks. And as you can see in this image right here, this is kind of what YOLO does. It gives every single subject their own bounding box and unique ID. So this is an image of me and my grad student, Johnny. Shout out, Johnny. And Johnny is assigned ID1 here with that blue bounding box, and I am in the background assigned ID2. So for our joint level checks managed by MediaPipe, we kind of have two, they kind of go hand in hand. We have joints in frame and occlusion. So for joints in frame, we are tracking the 6 key gait joints, which are the hips, the knees, and the ankles. And we are essentially making sure that it is not going out of the frame for a specific amount of time. Like I said, it goes hand in hand with occlusion, which essentially checks the same thing as joints in frame, however, during the frame, right? So kind of that occlusion case, like I mentioned, with the chair. So you can see how like the joints themselves are actually not confident and swaying away from my ankles themselves. So what actually happens when a check fails? And that is where we send it off to our LLM feedback. So at the top here, we have two cases, a pass fail and a fail case. And the fail case would read something like, the recording failed. The primary problem was that parts of the subject were blocked from view during the walk. Please ensure the walking path is completely clear of any objects or people. And likewise, the pass will obviously say that the pass passed. So kind of more into how it works mechanistically, we can structure it into a 4-step process. So initially, after we run it through our pose estimation model, we get a raw quality control output. And this output will be around 20 lines long, consisting of every single check, their pass fail value, and details if it requires. So clinging on to that occlusion case, we have MediaPipe occlusion pass, and it is a fail, given false, and it has some details. Right knee occluded 30 frames, right ankle occluded 19 frames. So from there, we reorganize and restructure it into a JSON file that is being sent to an LLM. The LLM phrases it and makes sure that it is a plain language, easy to read for a clinical setting. And that is how we get that clean result. So you see right here, we're able to take a raw output like this and then translate it into this for a front-facing clinical UF. So like I mentioned, it is a clinical facing UI, and that is kind of where we drifted off and got into mobile integration. So essentially, we took that desktop pipeline and we tested a set of 18 clips with it. Those 18 clips ranged from confident fail, we had marginal clips, we had pass clips, and confident pass clips. So the most important part actually was the marginal cases. Because when we are recording a video, say we are testing whether all of the joints are in frame, so we are testing a walking video where we actually get too close. Decoding too close is different for an Android versus an iOS versus a desktop. So that was really important, and that is how that's kind of the stuff that I was thinking of when I was integrating the Android and the iOS. So the Android was coded through the Kotlin programming language, and iOS was coded with Swift, and we were able to land on the same verdicts for those exact 18 clips as the desktop. So here on the right is kind of an overview, a snapshot of how the iOS and the Android app look. On the left here, we kind of have the iOS, and the right, the Android. And as you can see, they have some pretty basic functions here. We have the ability to record a video, upload a video, and then that is the feedback that I was talking about right under in the green and red. So we see a case where the recording passed, and then we see, please re-record the video with that LLM feedback. So right now, with what we were doing is actually benchmarking, and this will be a primary focus for the next couple months. So we have a clip set of 120 clips across 4 subjects, 2 devices, and 3 locations. And essentially every single subject ran through the same 9 checks. So we have a regular baseline walk. We have a walk where we are getting too close, a walk where there is a trash can in the way, 3 different tilt levels, all normalized and standardized, like left 10 degrees, right 10 degrees, etc. And then person count, which is actually kind of special. We had 3 separate cases, right? So for all 3 of the person count variants, we had the primary person who was walking a regular baseline walk. And then in the first person count check, we had a bystander kind of just standing in the back. And then the second case, we had that same bystander kind of walking around, not making too much noise in the background, but just a regular walk. And then the third case was an aligned walk. So while the primary person is walking that baseline walk, this bystander is kind of walking with them. And that is essentially to simulate a clinical setting. Because when we are looking at these recordings, we have the patients who are walking, but then there are clinicians who are present in the background. And that is important. Like I mentioned, that person count case with me and Johnny, that should actually be acceptable if it meets a certain amount of criteria, right? If we are in the back or we are making some movement. So essentially, the point of the paper is to be able to know where to draw that line, right? We don't want a pipeline that is too strict and is rejecting good videos, or a pipeline that is too lenient and accepting bad videos. So we're kind of trying to find that right line and see where it holds for every single subject, device, and location. So like I mentioned, we have the every single subject, and they are all ranging in body weight and height, and they all have different walking paths. And like I said, for the device itself, it's kind of the decoding where every single camera kind of sees differently, different for the iOS and the Android, and the location just to get a feel for a bunch of different natural environments. So I want to give a special shout out to my subjects in the back, Johnny, Sophia, and Jill. And note that this work was sponsored by the NSF REU. So thank you.